Hello everyone and welcome to the ApertureDB tutorial. Today we're going to be covering some of the basic aspects of how ApertureDB works and how you can use its API to retrieve and query all the information that it's on ApertureDB. Alright, so here are the topics that we're going to be covering today. We're going to go over the basic concepts on the ApertureDB API. We're going to be running some sample queries on a Jupyter notebook that we made available at this address. We're going to be using the WebUI and doing some basic operations on the WebUI to see how we can use this tool for debugging and getting an understanding of what's going on and getting information of what it's on our ApertureDB instance. And we're going to be using the data loaders to load and essentially ingest data into ApertureDB. This is going to be for both images and metadata information. Before we get started, it would be nice to have some basic understanding of how ApertureDB works and what are the different ways that you have to connect to a database and start writing some queries. ApertureDB implements a native API, which is completely JSON-based. All of its documentation is publicly available, and you can get a really good sense of all the features that ApertureDB does by going to that documentation page and reading through all the different features that we support. That is the entry point and the way that you essentially interact with ApertureDB. This native API, it's a query language that allows you to retrieve and interact with all the pieces of information that are on the ApertureDB instance. We have a set of connectors that allows you to create a connection to an ApertureDB instance and start running queries. And on top of some of those connectors, for example, on top of the Python connector, we have implemented an object mapper API that allows you to more easily interact with the objects on ApertureDB without having the need to write these native API queries. And it's especially useful for writing your applications. If you're using Python or if you're using Jupyter notebooks, you can use any of these connectors or object mapper API to interact with ApertureDB. All of these things are part of the application layer, and they can be, all of these connectors and object mappers are essentially helpers for you to connect to a database and retrieve or insert data into the instance. We also have a C++ connector that allows you to either write your own applications, or in our case, we use it to implement our REST API, which is also available for you. Today we're going to be looking into our WebUI, which uses the REST API to run queries on ApertureDB. And of course you can write always your own application that uses either the Python or C++ connector to interact and query ApertureDB directly. All right. Now we should cover some of the basic concepts on our API so we can start writing our own queries and make use of ApertureDB API. ApertureDB implements a graph interface, meaning that all the objects in the database are either a node in the graph or a connection in the graph. So the two basic abstractions that ApertureDB provides are objects and connections. Each object is essentially a node in a graph. It's represented as a node in a graph. But these objects can be of different types, right? We can have an object of type entity that can be, it's a general purpose abstraction that is useful to represent any piece of metadata that you need for your application. Let's say that you have something like a person or a product. You can represent that person or product with their specific properties using the entity abstraction. In the similar manner, if you have specific types of nodes in the graph, like an image or a bounding box or a video, we have special support for that type of objects, and we provide special functionality for them. And we have support for more abstractions that are very useful, especially in the context of visual applications, like polygons and clips and frames. And we also have connections. That connections essentially represents relationship between the different objects that you have in the database, and those can be used to do graph traversal operations. Another very important concept is the commands. When you write a query into ApertureDB, that query is composed by a sequence of commands. And the most basic commands that exist are the add, find, update, and delete commands, which essentially allows you to are modifiers of the specific objects. So for each object or for each type of object on ApertureDB API, there is a command for doing an add, find, and update and delete. So for example, in the case of the image type of objects, you will find that our interface provides commands for doing add image, find image, update image, and delete image. And the same is for the other types of objects that are part of ApertureDB interface. And we also have other type of commands that are special that do not necessarily apply operations or apply any actions on top of those objects, but are rather useful for doing other things with the database. For example, get the status of the database, to get the version and whether or not the database is accepting request. You can compute the schema, you can create indexes, remove indexes, and there are other special commands that you can use. All right, and those are an enough number of concepts that we can start putting into practice. For that, we have made available an instance of ApertureDB displays that you can connect to and start using ApertureDB, and we're going to be running some queries here. So before we get there, I just want to very briefly show you how our WebUI works. We're going to be just logging in to see that we have as a starting point an empty database, and this is just the status page of our WebUI. And what we can see here is some information about the version of the database and some basic information about the status of the system as a whole. And you will also find information about the objects and connections and some information about the data distribution and a summary of all the objects that you have on your database. Right now the database is empty, that's why you will not see any information here. But after we do the initial population or ingestion of data, you will see that how the objects will start to appear here. So let's get started with the basics. Here we're going to be using a Jupyter Notebook, and we're going to be using ApertureDB Python package, which it was previously installed. It is available through pip, so all you really need to do is to pip3 install ApertureDB, and you will have the Python package up and running. And the first thing we're going to be doing is from the ApertureDB package, import the connector so that we can establish a connection to a database. And here what we're going to be doing is creating a connection handler where all we have to specify are the location of the database. In this case, we're going to be using the default port, so we don't have to specify any port. And we're going to be specifying our credentials, which are user and password. So ApertureDB implements role-based access control, and we have the ability to, generate roles and users and assign passwords and API tokens to every user. So we're not going to be covering that in details today, but you just know that you need to have a set of credentials in order to connect to ApertureDB. So here we're going to be sending our first query, which is a very basic query. We're going to be sending a get status command, and we're going to be sending an empty get status command, which will give us a predefined response. So all we really need to do is use our connection handler and write a query, send the query, and what we're going to get as a response is a response which is in the form of JSON and a set of blobs that in this case is going to be empty. So let's go ahead and run this initial query. And as you can see, when we print the last response, the same way that we send a JSON object as the query, we get a JSON object as, in this case, it's a JSON array with multiple objects for the response. And in this case, for the get status command, we get information that the database is okay. We get status 0, meaning everything's well, and we get a version for that for the running instance of the database. So that's it. That's how we run queries into ApertureDB. So the information that is collected here is essentially collected through a similar schema or a similar way where the WebUI frontend just sends a query into the ApertureDB instance to collect information about what is the status of the database. All right, so we ran our first query into the running ApertureDB instance. We can see from here what is the structure of a query and what is the structure of the response. But let's go into a little bit more detail with that. One of the core concepts of the API is a query. So a query is a sequence of commands that are performed transactionally. A query is essentially composed by two elements: a JSON array, which is an array of commands, and optionally an array of blobs. So this array of blobs is usually useful when we want to insert some data into ApertureDB. For example, let's say that we want to insert an image. We're going to be using the AddImage command in that case, and we're going to be sending the image as a blob, which is the JPEG, for example, the encoded JPEG image. We just send that as part of our query. And the size of the array of blobs depends on the command. So in the example that I was given before, if we just do one AddImage, the array of blobs will contain just one blob corresponding to that image. But if, for example, we want to insert two images in the same transaction, the JSON array is going to have two commands, two AddImage commands, and the array of blobs will have two encoded images, two blobs each corresponding to each of the AddImage commands that we send. And in a very similar way, we have a response to every query that we send. We get a response. So a response is a sequence of JSON objects that correspond to each command in the query that we send. So if the query has n commands, the response will also have n JSON objects, unless there was an error, which is kind of a special case. But a response is composed by two elements, essentially. A JSON query, a JSON array. In the same way, this is an array of objects that correspond to the commands. And optionally, you also get an array of blobs. In a similar manner, if you, similar to what we send on the query, if we do a query where we want to retrieve an image, well, that array of blobs will contain the image as part of the response. And the number of blobs that we get in response correspond to, it essentially depends on what is the result of the query that we sent. So let's put this a little bit more in practice with a specific example for doing an insertion of an object. So we're going to be using one of the add commands. So the add commands have certain parameters like properties, or if not found, or connect, or even a reference that can be used to modify the behavior of that addition. So let's start with the most basic example in which we want to just go ahead and insert an object. In this case, we're going to be inserting an entity. So our query is going to be composed by a single command, which will be AddEntity. With AddEntity, because entity can be used to model whatever your application needs, you have to provide a class. So in this case, we're going to be inserting an entity object with the class person, and we're going to be associating a set of properties to that specific person. These properties are stored as part of the same node in the graph that we can use later for querying. So we're going to create here a new entity of the class person with a name and last name, and we're going to be running that query. In this case, we don't need to specify any blobs field here because the AddEntity does not require any blob. We're just dealing with metadata here, so we can just send the query as is, and we're going to get a response, and as always, we're going to get a set of blobs. In this case, the array of blobs is going to be empty because we're not doing any retrieval of data. So we can just go ahead and run this query, and as you can see, we also get a response here, and the response has just this object, which has the command that we use, the AddEntity command, and we have some information about what happened. Here we're getting status 0, which means that everything went well and this insertion worked correctly. Maybe the best way to verify this is just to go to the WebUI, and we can recompute the schema to see what is the information on the database. And as we can see here, we have now one object of the class person with the properties that we have just added. In this particular case, the two properties are string properties, and we didn't create any index for them, so we will see that the index field is empty. We're going to be creating an index later on. So the next thing that we can do is retrieve this information that we have just inserted. How do we do that? With the find command, in this case, FindEntity. So we're going to be writing a new query. That query is going to be FindEntity, and we're going to say that we want to find all the entities with a specific class, which is person, and as a result we want to get all the properties associated to those objects. So we're going to just go ahead and run this query, and as you can see, we get as part of the response status 0, meaning that the query went well. We get a number of return objects, and here we can see all the different objects that are returned in an array. So in this case, we just have one object that has a name or a last name, a name and a last name, and we can see their values. In a similar manner, we can modify what the response is going to look like by retrieving a specific set of properties. So for example, we can just go and retrieve the name for each of the objects, in which case this is just going to be composed by the name, or we can specify multiple properties. So I just want to get the name and the last name as a response, and that is what I get. The next thing that we can do is make an update on that entity. In order to make an update on that entity, we're going to be using the UpdateEntity command, and we're going to say that we want to apply an UpdateEntity for objects with the class person. And we're going to constrain what those objects are, because essentially we want to make an update on only just one object. So we're going to be using the name and the last name to uniquely identify that object. And we're going to simply add another property to that object. In this case, we're going to use my email address, and we are going to go ahead and add that specific property to the user. One interesting thing to note is that you don't have to predefine any schema beforehand. You can just keep on adding new properties to the objects, to new objects or objects that already exist, and there is no need for a predefinition of what the schema is going to look like. We're just going to go ahead and run this UpdateEntity, and we get as a response status 0, meaning that everything went well, and we also get the number of objects that were modified as part of the query. So if we go back to our WebUI, we should be able to see that now when we reload the schema, we have an email as another property of the person with of the type string. And in a similar manner, we can just go ahead and run the same query, but we can add the addition of remove certain properties. So we can specify that in this array, and let's say that I want to remove the last name on the objects that match these constraints, and when running this, we'll get again status 0 and the number of objects that were modified. And if we come back here and recompute the schema, we'll see that the last name is no longer there. So UpdateEntity allows you to modify those nodes in the graph or those objects with their specific properties, and you have the option to add new properties, modify properties, or even remove some of the properties that already exist. So let's say that I want to update a specific property. We can just change the name to John, and we can just go ahead and because we no longer have someone with the last name, we're just going to remove that, and we're going to run the query again, and you will see that we get status 0 and the number of objects that were modified, and we have now modified the name to John. So the next time that we run this query, we're going to get a message indicating that there was no object which match these constraints. So we go ahead and run that, and as we can see, there were no objects to update, and that's why we get status equals 1, meaning that the query went well, but there were no objects found to perform the update. All right, let's go and look into a little bit more details. The next thing that we're going to be doing is doing some bulk uploading of data. But before we do that, actually, let's insert an image. into ApertureDB. So how does that work? We are going to create a new block here, and we are going to create a new command from scratch. So let's get rid of this, and let's do an AddImage. And when we do an AddImage, we can specify properties for that image. And let's say that we're gonna add a property to the image called type, and this is going to be a bird, because as an example, we have some images of birds on our folder. So we have our input folder here with some images that we can use as an example. And actually, let's use this image of a plane. So let's do this, and let's, as part of the insertion, do some first we need to get the blob corresponding to the images. So we're gonna do image equals file open input images JPEG, and the next thing that we're going to do is blobs equals image dot read to read the encoded image as it is, as a JPEG, and we are going to pass the blobs here. So before that, we're going to change the type to airplane. And that way we are adding a new image, adding a property to that airplane. We can add other properties that can be of a different type. Let's say age. Let's say that this plane is 18.9 years old. And we're going to be running that query, which in this case is both composed by a JSON command, which is the AddImage, and a blob corresponding to the encoded image. So let's run this. This is open, and let's run that. All we are missing here is that we want to open this, the mode in which we want to open this image, which is read binary. So we run that again, and we actually get a status 0, meaning that everything went well, and we should see that the image was correctly inserted here. So let's recompute our schema, and as you can see here, we have our new image that has two types of properties. One is a type, that is a string, and the other one is the age, which is a floating point value, because that is what we specified. And we can even use our image search functionality on the WebUI to find the image. So let's say that we want to find all the images that are greater than some arbitrary floating point number. And when we run that, we get the image that we wanted, the image that we have just inserted. And we can even go and retrieve all the properties associated with the image and rerun the query so that all these properties are shown here. So we have certain functionality here, as all of the queries that are done and performed here are essentially translated into a sequence of commands. And here we specify exactly what are the commands and how the queries form. In this case, because we are also saying that we want to retrieve the bounding boxes, you will see that we have this command for finding the bounding boxes associated with the images. So we can run it without, and we're just going to have, in this case, one command, which is the FindImage, and you can always see what are the result for that. So the WebUI and the image search is especially a good tool to run some sample queries and see what's going on in the database and get a glance of what is the information present on the database. You can also come here to custom query and run the same query. And in this case, you can run whatever query that you want there. And you will have access to the gallery here to see all the different properties and the objects that are the return value of that query. So we have just added an image and we are good to go. Another thing that we can do is simply delete an object. So let's use the WebUI and the custom query to do that. So for that, we can simply say delete image, and we can say constraints. We will just use the same constraints, and we're gonna keep everything the same. And if we run this query, here we can just get the results, and the result says that delete image status 0, meaning that everything well, and we get a count of the number of objects that were deleted. So if we go back to status and recompute the schema, we'll naturally see that the image that we deleted is no longer there. So with that, we essentially went through the process of inserting an image and both retrieving that image through the WebUI and the image search functionality. And of course, if we run the search now, we won't get any result. We can see what are the results that we're getting here. We're not getting any result as a result of the FindImage because we no longer have an image. And we also went through the process of doing a delete image, which it's the same way that we can delete an image, we can delete any object in the graph. So the next step will be to do some data ingestion. And for that, we can use our data loaders. So here we have built 3 CSV files that can be used to ingest data using our Python package and some of the functionality that it's present there. So here is just a basic print of the 3 CSV files. These are separate CSV files that we're just printing here for convenience. And those CSV files have a specific format to follow in the header. But if you follow that format, the ingestion into ApertureDB, it's very straightforward, as we're going to be showing you here. So what we're going to be doing is adding 4 objects of the type person with the specific properties of name, last name, ID, age, height, and a flag indicating whether or not that person has a dog and a date of birth. And we're going to be doing some conditional add based on the ID of the person. We're going to be covering that in detail later on. The second CSV file has the information about specific images. So we specify the file name for the images and some properties that are going to be associated to those images. So in this case, we have a license, an ID, an age, and height, and whether or not there are dogs associated with those images. These are arbitrary properties that you can define for your objects. And finally, the other thing that we're going to be doing is ingesting the connections between the image by ID and the person by ID, and that connection will have a specific property. In this case, we define that property as confidence with a floating point value. So we're going to be ingesting these 3 CSV files, and we're going to see how the database start populating with this information. So in order to do that, we have to import a set of packages that we have. So one of them is the we don't need the status package, but we can use the connector and the entity and connection loader and the image loader. And here we specify some of the information just for convenience purposes. And the good thing is that the loaders support batching and concurrent upload. So we're going to say that we want to upload with 32 threads in parallel and batching size of 32. This will significantly speed up the operation when you are ingesting a large amount of objects. And the next thing that we're going to be doing is instantiating a connection the same way that we did before. We're going to take the CSV file of people first, and we are going to use the entity loader to specify the ingestion of the CSV, of this CSV file. So all you really need to do is create a generator using our classes that are included in the Python package, and pass the CSV file, and then using an entity loader you can ingest all of that. So you just need a very few lines of Python code if you want to do this data ingestion. So let's run that. Let's remove this. But this ran correctly. It did 100%, and it says that a total of 4 elements were inserted. This error that we're getting is because some instructions that we had there that are not related. But the information about the data ingestion went correctly, and everything looks fine. So we can go here to our WebUI, recompute the schema, and see that right now we have 5 people. The first one that we originally inserted, and 4 more that we have just inserted. And you can see as well that we have a bunch of new properties associated to those entities of the class person. Next thing we're gonna be doing is the ingestion of the images. So we're gonna be ingesting those images from the CSV file. That process is really fast because there are just a very few number of images. You have some information there about how the ingestion went, and we can just go and verify now that we have 5 new images on the database, and some of the specific properties that we have there. And finally, we're going to be doing the ingestion of the connections. We're going to ingest some connections between the people and the images. So we can just go ahead and run this, and as you can see, we get some information about the connections that were inserted. And if we go back to our WebUI, we can see that right now we have connections of the class has image, and we have the origin and the destination of those connections and the types for that, and some of the properties and the type of the properties. So right now we should be able to just go and run a search. In this case, we're going to run an empty search, which is going to return all the images on the database. We can even go and specify that we want to see what are all the properties, run the query again, and we can go to the gallery and see what are the different images and the different properties for those images. Another thing that we can do is if we don't want to use the web UI to see what's going on and what is the information that you have on the database, you can always programmatically retrieve that information using the GetSchema command. So we have more information in the link below here, but essentially by running the GetSchema command as a query, you can get all the information about the different connections and objects that you have in the database and their classes and all the different properties and types. So this is very useful in case that you need to programmatically access and retrieve information about the schema composition of the database. All right, let's look into some other things that we can do with ApertureDB. We are going to be using part of our Python package to display some of the images that we're going to be retrieving from ApertureDB. We're going to be doing the standard creation of the connector, and we're going to be running a couple of queries to actually retrieve the images in this Jupyter notebook and display them. So what we're doing here is doing a FindImage command, and we are applying certain constraints by one specific ID. This will in turn return one image because this is a unique identifier for the image. And in this case, we're indicating that I want to retrieve all the properties associated to that specific image. And this is the default value of the blobs parameter that it's set to true. So we can just remove it there, and we'll see how it behaves when we change that a little bit later. So by doing this, we are essentially retrieving one image. We know that it's going to be one image because we're filtering by one specific unique identifier, and we can just go ahead and run this query. And as you can see, in this case, we are getting both a response in the form of JSON with all the properties that we requested, and we are also getting the encoded image as a blob, which we have a helper function here to display that image. So as part of the response, you get both a piece of JSON and an array of blobs. And in this case, the blob corresponds to this unique image. We can also modify the query by saying blobs equals false, which will essentially tell the server that we don't want the image in return. So we can see that we will get no image in return by printing the length of blobs as the response. So let's do that. As you can see, in this case, we're getting no blobs, whereas if we set this to true, we are actually getting one blob. So this is a parameter of the find command, of the FindImage command, and it's specific to certain type of objects. For example, images and videos have blobs. So you could potentially decide whether or not you want to retrieve that blob as part of your query, or if you're only interested in the metadata associated with the object. But there are some objects that do not have blobs, like entities, person. There is no available parameter for blobs. Now, how do you know what are the parameters for each of the commands? Well, all of that is documented on our publicly available documentation. So let's go here to FindImage, for example, and we'll get a list of all the different parameters that are available for that specific command. So let's use FindImage to go over all the different parameters, and let's do a quick explanation of how they work. The first one is a reference. A reference is the parameter is called _ref, and that parameter essentially allows us to define a reference that is going to be used within the transaction. Where I'm going to go into a little bit more detail on the next example. We have another parameter which is called unique. Unique indicates whether a single object is expected, and if that is not the case, you will get a message indicating that. You also have the parameter as format. As format allows you to specify what is the return parameter for the image. Actually, let's use that in an example. So here, because we are retrieving the blob, we are just showing the image. But we can also do a change in the format of the image. So we can say as format. The images are stored. The original images were inserted as JPEG, so their default retrieve value is going to be JPEG, but I can specify that I want to change that retrieve value to be a PNG. So that will essentially do a transcoding of the image on the fly and send that as part of the return. Of course, we're not going to see any difference because it's only a change in the encoding, but one of the things that we can expect is that because it is a PNG, the size is going to be slightly larger. So let's actually check that. We can print the value of the first element of the blobs array for the case of, this is going to be encoded image size, and we are going to have here the size in terms of number of bytes for that response. So if we do a JPEG, or if we do nothing here and we get a JPEG as a return, we see that the number of bytes, actually let's put this in terms of megabytes. Let's see. So the size of the image is 0.16 megabytes. Let's even do it kilobytes, so 170 kilobytes. And this is the size of the image as it is stored in ApertureDB. But if we actually re-encode the image as a PNG, because PNG is lossless, we expect the size to be increased in the encoding in the final encoding of the image. So when we run that, we see that the actually return image is slightly larger. Well, it's a few times larger because we are using a different encoding and different format for the image. We can, of course, if the image was originally stored as a PNG, for example, we can change that format to be a JPEG. And in this case, because we're doing a re-encoding of the JPEG, we would even expect that the size of the image will be smaller. What other parameters we have here? So we have blobs, which we briefly cover, which essentially indicates whether we wanted to return a blob as part of the response. So on FindImage, that blobs, the default value for blobs is equals true. We have the unique IDs parameter, which indicates whether or not we want to return unique IDs as part of the response. So what we have here, because we're retrieving all properties, the unique ID will be returned. But let's say that instead of doing this, I want to retrieve some specific properties like the age and the date captured of that image. And if we go ahead and run this query, the response that we are going to get is just those values. But I can optionally say that I want the unique IDs to be part of the response. So I can set that flag to true. And when we run this query, you will see that we are retrieving the unique ID corresponding to that specific object. We have the constraints parameter, which is the one that we are already using here to constrain the search. And one other thing that we can do is let's give this a try. Let's see if there is any other object in the database that has an ID higher than this one. Maybe there are a few. Okay, there is just one more. That's why we get 2 results. But the constraints parameter essentially allows you to specify the constraints of the search based on the specific properties for that object. Another possibility is doing is connected to, which will allow us to check whether or not that object is connected to another object in the graph. We're gonna skip that for now. We're gonna do that on another example. Then we have the results block, which is something that we have been using to specify what are the properties that we want to in return. And we can even do things like sort. Let's say that I want to sort them by age, right? I can specify that. And forgot to come here. And in that case, what you'll see is that the one with age 45 comes first, where in the case before, it was just a different order. You can actually go into results to see all the different parameters that results accepts. And one very interesting parameter of images and of other specific objects is the operations parameters that allow us to specify different types of operations that can be applied to the image. For example, threshold, cropping, and resizing, right? Let's do a simple example with resizing, and let's actually show that image how it is resized. So let me remove this and let me remove this, and we're gonna define as part of my query. Oops. Let's go back to the original query. Let's say that I want to get a resized version of this image because the original image stored in the server is too large. I don't want to, retrieve the entire image. I only need a 224 by 224 version because I want to feed that to a ResNet network that I have built. So I'm gonna use the operations block to essentially specify a list of the operations that I want to be performed on the image. So we're gonna specify a resize operation, and we want to say that the new width is going to be 224 and the new height is going to be 224 as well. So let's run this query. Forgot the comma here, and as you can see, I'm getting a smaller version of that image. Of course, that image is, the size is going to be much smaller because we are resizing the image down. And yeah, we can actually do as many operations as we want. We can even do let's, for example, do a flip operation or even a rotate operation. So we can rotate the image for with an arbitrary angle. So we can try that. Let's say that I want to apply another operation of the type rotate, and the parameters of that, I guess the main parameter here is the angle of rotation. We can say 45 degrees. Let's run that. What did I forget? So let me see the response that I'm getting. Oh, this is probably a floating point value. And maybe there is another parameter that I need to include. Yeah, the resize, whether or not that is true or false. So this indicates whether or not we want to do a resize operation after the rotation is done. Because when you rotate the image, if you want to have the full image within, you need to essentially change the dimensions of the image so that the image fits correctly. So we're going to say resize equals false because I don't want to resize the image. And you will see that I get the rotated version of that image. So let's take a look at what happens if we say resize equals true. You will see that the original size of the image is kept, and the image was rotated 45 degrees. This is following the OpenCV notation for the parameters of a rotation. We can change this. Let's rotate it to 90 degrees. And as you can see, we're just going to be, looking at that specific rotation of the image. You can concatenate as many operations as you want here. We can even define just the width, and the height will be changed proportionally. And in this case, we're going to get an image that maintains the original aspect ratio of the image because we're just modifying one of the dimensions of the size. So with the parameters of FindImage, we can essentially modify what the resulting image is going to look like, and we can apply as many operations as we want. And the same behavior works for videos, bounding boxes, and other types of objects. So let's move on into another example where we're going to be adding a bounding box to that specific image. And here I have a query that, rather than having just one command, as most of the queries that we have been doing so far, we're going to be doing two commands. In reality, you can have as many commands as you want, and all of those commands that are part of the query will be performed transactionally on the database. And in this case, we're going to be using FindImage, and we're going to introduce the concept of ref. Ref is nothing more than a reference to whatever is the result of this command. And that reference can be used within the transaction to indicate that we want to create some sort of relationship, or we want to check for some sort of relationship between the object or the list of objects referenced by the result of this command in another command in the transaction. So, for example, in this particular case, what we're saying is that we want to do a FindImage with the same constraints as we were doing before. We do not want to get the blobs associated with that image, but we want to declare reference, meaning that I am going to be using whatever is the result of this command within the transaction. And that happens on the other command. So the other command that we're going to be using is AddBoundingBox. So BoundingBox is a type of object on ApertureDB the same way as image. That's why BoundingBox has an add command associated with it, right? So we're going to be doing AddBoundingBox. And we're going to be using that reference because we are going to associate the bounding box to the specific image that we reference here. So we're going to be using that reference in the image parameter of the AddBoundingBox. So in order to understand that a little bit better, we can just go into the AddBoundingBox command here, and you will see that one of the parameters that it supported is image, which is a reference to a single image within the transaction. That single image within the transaction is whatever we get as a result of here. So what this query is doing is finding one specific image by this constraint, declaring a reference, meaning that we're going to be using the result of this command later. And in the second command, we are using that reference, and we are also specifying what are the parameters of the bounding box. Again, this is a parameter of the AddBoundingBox command that we are probably gonna find it here. And here we have a little bit explanation of how this rectangle parameter works and how we can use it. But it's yet another parameter of the AddBoundingBox command. So we're going to be using the rectangle parameter to define what is the X, Y position and the width and the height for that bounding box. And we can optionally add a label to that parameter. So remember that this image was, let's remove these operations for the time being. Let's run this. And this is the image that we have. So the goal is to create a bounding box around one of the people here. So we're going to be running this operation. So let's go ahead and run that. And as you can see, what we have is the result of the FindImage set status 0, meaning that everything went well, and return 0 because there was nothing to return. We just used the FindImage to declare the reference. And the result of the AddBoundingBox is also correct because we just get status 0, meaning that the bounding box was correctly inserted. So if we go to our WebUI and reload the schema, we'll see that now we have one bounding box, and the bounding box has the following properties. So you will notice that these properties have an underscore before the name of the property, and this is because these are system-defined properties. These are properties associated with the object that have a special meaning on ApertureDB, and these properties can be used to provide certain specific functionality. We can actually go to our image search and let's find all the images, and let's indicate that we want to retrieve all the properties, and we actually want to include the bounding boxes. And because right now we have a bounding box associated with this image, we can go there and you can see that we added that bounding box. Now it seems that the quality of the bounding box is not very good because it was just the numbers that I pick here, and apparently they're not that good. So one of the things that we can do is just go and change this bounding box. So here we have some options to display the information on the bounding boxes and the labels. We have the ability to add a new bounding box on our WebUI, which is essentially the same that we did with our Python command with our API, but you have the option to do it on the WebUI. But the other thing that we can do is just edit this bounding box. So let's do that. What I'm going to do is just change this bounding box. And actually, I want the height of the bounding box to be longer. And I want the X position to be slightly to the left. So I'm going to say 100. Let's see whether or not that's okay. That's much better. We can edit the bounding box again and even change the label. So for example, let's say that we have a classifier and this is actually person 1, right? We can change the label, and we can keep on changing the values of the bounding box to whatever are the correct values. We can even go from here and remove this bounding box. But before we remove the bounding box, let's go and see how we can have access to retrieve that bounding box using our interface. And it's another way of using the reference of a concept in the isConnected parameter of a find command. So what we're going to be doing here is doing the same find image we did before, but now the goal of our query is to find the image and find all the bounding boxes associated with a particular image. So how do we express that query? We first do a find image as we did before, declaring a reference and specifying the constraints. And later we do a find bounding box in order to get all those bounding boxes. And we're going to be using this parameter, which is called isConnected2. So isConnected2, you'll find all the information about that in the find bounding box. You'll see all the parameters that are here. And isConnected2 is used to express a constraint on the neighbors of the object. So essentially what we are doing here is saying, I just want to find the bounding box, but only those bounding boxes that are connected to whatever was declared on reference 1. So you will notice that here reference has an underscore. That means that I'm declaring a reference that is going to be used to reference to the objects that are the result of this command. And here I'm just using ref, meaning that I'm going to be using a reference. So I'm going to be saying, I want to find all the bounding boxes that are connected to whatever is the result of ref1, in this case, this specific image. And I also specify that I want to get in return the coordinates of the bounding box and the labels of the bounding box. So we can just go ahead and run this query. And the one thing that I'm going to be adding is I want to see what is the response for that. So we run that, and the response that I get is the actual image, because I didn't specify blobs, and blobs here by default is true. So I am getting one image as a result, but I am getting no properties because I didn't specify anything on the results parameter. And I'm getting status 0, and I'm also getting the bounding boxes and the coordinates of the bounding boxes as I ask. So you'll see that now we have the label, the modified label that we modified on our WebUI, and all the coordinates corresponding to that bounding box. And we are using some of the helper functions that we have in our Python package to essentially show the bounding box in this Jupyter notebook. With that, we introduce some interesting concepts, like more importantly, the reference, which is something that is done every time that you want to find objects that are neighbors or connected to some of the other objects. You have to use references. And we also look at how we can interact with bounding boxes and what are some of the native support that we have for this specific data type. All right, so here's a list of what we have learned today in the last hour. First of all, we learned about some of the basic concepts on ApertureDB API and what are some of the things that you can do. We had some hands-on experience on running some sample queries on Jupyter notebooks. We learned how to use the WebUI and learn some of the basic functionality that our WebUI supports. And we use data loaders to do some basic initial ingestion of data into ApertureDB. With that, we conclude the initial tutorial on ApertureDB. And if you have any other questions, please reach out to the ApertureDB team or look into our documentation, where we have more explanation and examples and a full description of all the different pieces of functionality that ApertureDB supports. Thanks for watching.